Hello, 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 hello. Curve sketching. So this is a major part of the course, something we've been building towards, taking derivatives, looking at increase, decrease, concavity, and whatnot. Okay, the idea is we want to be able to sketch a curve accurately. Okay, let's go through these 8 steps one by one, just briefly. Lots of examples to come, but just to outline the technique to begin with. So domain is pretty straightforward. You're looking at, for example, domain of f of x equals root x is x bigger than 0, or you can write that as an interval 0 to infinity and never include infinity. So domain of the function. The set of x values that I am allowed to plug in to the function. Intercepts, part B. So 2 forms. We're looking at the x-intercepts or the y-intercepts. So where does my curve hit the x-axis, and where does it hit the y-axis? Let's use the word touch. Where does the curve touch the x-axis? And also we want to know where it touches the y-axis. So hopefully you can see we're building a picture piece by piece, and then at the bottom we'll put it all together. Symmetry. Symmetry I'm going to typically skip. Okay, you're looking at, if you're interested, sometimes you can save a little bit of time by looking at whether your function is symmetric, okay, whether it's an even function or an odd function. Okay, this is sometimes a bit useful, but I will generally skip this. But feel free to make use of symmetry as you see fit, or ask me about it. Asymptotes, vertical asymptotes. So we have vertical asymptotes, v dot a is the usual short form for vertical asymptotes. And we'll also look at horizontal. Okay, intervals of increase and decrease. We just talked about that, so I won't belabor that point. So it's obviously important to find out when your function is increasing, when it's decreasing. Okay, you also want to know where the local maxes are and the local mins are. You want to know when it's concave up. You want to know when it's concave down. And what this boils down to a lot of times is, kind of just plotting the local max and local min values and connecting the dots in an intelligent way. So connecting the dots intelligently, meaning using what you know about concavity and what you know about the intervals of increase and decrease. Okay, asymptotes can kind of make things more complicated, but we'll deal with that as it comes. Anyway, so hopefully you can see how we're going to take all this information, A, B, C, D, E, F, G, and bring it together to try to form a sketch. So lots of examples to come, but here's the outline of our technique.